So good morning, everybody. We appreciate all of you spending some time to have a little training in the busy of days and back-to-backs. So on behalf of myself, right, and of Garland, appreciate everyone's time to dedicate to this. So the purpose of today's training or call together with our partners at Garland isn't necessarily to introduce Garland. All of you are familiar with Garland in some form or fashion, probably have even worked with Garland in some capacity or in other, past deals. The purpose of today's call is, besides a recap of what Garland does and going into their hardware here, is during trainings or during sizings, I should say, that's usually the hardest part of our job, right? Number one, because it can get kind of complicated. On the fly, we have to be listening to what our potential clients are saying, and at the same time studying their network diagrams, and then understand everything, ingest everything, and being able to come out with constructive feedback and ideas of how deployment's going to be. The more and more the business is going to lean on us as OT specialists to take over than these sizings for other SEs out there, right? The more pressure is mounting on us, right, to always have those answers. And it's not always easy. So as we're getting into more of these sizings that are more complex, Garland and I thought, what's a good training to focus on? All right, in these sizings, identifying where Darktrace is good, where are we going to be able to deploy, ingest that data to provide a very confident and a worthwhile POV. But in some cases, there might be complex environments like in oil and gas or water that everything's distributed, right? There's a lot of different sites. How can we leverage our partnership with Garland and then be primed in those sizing conversations to identify, wow, like this would be hard deployment just for Darktrace ourselves. We could definitely lean on Garland and deploy taps, aggregators, data diodes, whatever it may be here in order to get the data we need to have a very successful POV and to increase our chances for a tech win. So that's the point of today is we're going to go over certain scenarios and sizing of where Garland has helped us before to give you guys a good overview of, all right, in future sizings, and as you're helping out as OT specialists or on your own deals, when do you realize, okay, now would be a good time to bring in Garland? And I'll talk from experience, just by thinking about this together with Garland, with some of you, I've been in a couple deals now where I'm like, huh, I'm glad I've been having these conversations because now I'm primed because I'm listening to what clients are telling me. I'm like, oh, a tap would be good there. Oh, I wonder if I can speak with Jake and bring in Garland over here, and actually it's been successful. And that's the goal here, is to equip us to be better at our jobs for these sizings, right, and to increase then our engagement with Garland, right, and bring them in when needed, because ultimately they're here to help, and they're going to help us then gain more traction in that tech win when it comes to the more and more complex sizing scenarios and clients that we work with. So I talked a lot there, but that's kind of the name of the game today of what we're going to be going over. Appreciate everyone's time. Jake, let me turn it over to you guys to introduce yourselves, and then we'll get into it.
Perfect. Thanks, Jeff. And great to see everybody. Thank you for taking some time out of your day today. I see a lot of familiar names that we've worked with in the past. So little introduction to myself. My name is Jake Simon. I'm the partner engagement specialist based out of Denver, Colorado. I handle any tech partner and channel partner relationships in the field. So any trainings, events, social media campaigns, that all kind of falls under my purview. And I've worked with, various members of your team, especially with Jeff, over the last couple of years in formalizing this partnership and getting us to the place that we are today. So excited to have this conversation today. Pass it over to Caitlin.
Awesome. Yep. Thanks, everyone. My name is Caitlin Hutterly. I'm the partner manager for Garland. Been working with Darktrace for the last 2 to 3 years now. So definitely, looking forward to, connecting with the newer names and, continuing our relationship with all of those that we've worked with in the past.
And hi, everybody. I'm Todd Kane, system engineer for Garland. I support our West territory in Canada and a couple other territories on the pre-sales side. So I've worked with a lot of folks on the call here and doing those sizing configuration calls and working with customers to determine the correct solution. And I've been here with Garland for about 5.5 years. I'm located in the North Texas area. It's great to see everybody.
Perfect. So, just a quick agenda. We'll just do a very quick introduction to Garland. A lot of you have already seen some of these slides, but just a nice refresher, as well as on the product side. We'll transition into kind of that use case overview. So some of those deployment scenarios that Jeff was talking about in the beginning. And then we'll kind of wrap up with, what are the best ways to engage with Garland? What is it going to be easiest for both of our teams in order to see that full success? And then any questions or comments at the end. I do want to point out, we want to make this interactive. So anytime that, you might have a question during this call, either raise your hand, feel free to come off mute, ask that question away. We want to make this an interactive session overall. So, kind of transitioning into that introduction to Garland, right? We really believe at Garland that we're the foundation of the OT ecosystem. We believe that through, our taps, our packet brokers, our data diodes, and, that network visibility that we ultimately provide to those OT tools. Right. And all of that visibility is really through the network packets, right? And the truth really being in the network packets. A lot of the visibility that is discussed, especially in this industry, has to do with the data that is being passed to your tools. And we believe, right, if you're on any call with our CEO, he'll say multiple times in that call, the truth is in the packets. It's what our company is built around, and it's what we truly believe. And that's really, embedded through our tap to tool philosophy, which is how we work with Darktrace, right? So that's through our network taps, our data diodes, our packet brokers. They're all purposely built to deliver that network visibility and that network traffic to Darktrace, right? We're solely focused on delivering that full visibility. We have no desire to ever become a security or a monitoring company. All we're focused on is these core 4 products and delivering that full visibility to Darktrace. Now, a lot of our value prop really, lies in the fact that we believe the customer should have the ability to connect with ease and should be able to deploy in any OT environment, no matter the media types or the speeds within the network, right, or the overall connectivity within the network. We have different form factors where, we have large form factors to smaller form factors. We have, products that you could fit in your backpack and take with you on the go. We have specialized products that could be DIN rail mounted. We have speed conversion, media conversion. So we believe that, Garland shouldn't be the holdup in connecting Darktrace to the environment, right? We want to help you guys deploy in any OT environment overall. We also want customers to be able to, save time and money, right? One of our value props is, we shouldn't be the biggest piece of the budget overall, right? We want to deploy and put products into the network that could help customers, whether that's saving time and money or hiring additional personnel. And we have different products through our span aggregators, our tap aggregation, right? Or some of our other product line that Todd will get into here in a little bit that, really helps from that overall standpoint. So, that's definitely one of our larger value props here at Garland. When it comes to OT as well, right? A lot of the new regulations, whether that's NIS2 or NERC SIP, right? We want to help customers comply with the regulations that are being passed down, over this upcoming year and over the years to come, right? And a lot of that, especially when we're talking in OT, has to do with those, hardware data diodes and the unidirectional traffic enforcement that we specialize in. A lot of another one of the value props for Garland too. A lot of our network taps, they do not have an IP address or MAC address associated to it. So a bad actor in the environment, they don't even know that product is installed in the network, right? So it's helping safeguard the customer's environment overall. Of course, the fact that we're also made in the United States, that's a huge value prop for us as well, and helping us, accelerate business across the country. And then, of course, right, we do not want to add any additional complexities or risks into the network. We do that right through our zero subscription fee, port fee, licensing fee model, right? We want it to just be easy to add Garland into the network. A lot of what we say, if there's dust on our products after, installation, that's a good thing, right? That means you don't have to go in and and do anything to the actual product. It just sits there and works. So we do not want to add any, unnecessary complications or any risk into the network overall. And I will pass it over to Todd.
Thanks, Jake. Yeah, so as Jake mentioned, let's try to make this as interactive as possible. I'm going to be looking over here, by the way, because this is where I've got my presentation up on my larger screen. So if any questions come up, somebody raises their hand, somebody let me know, please. So, we're a tab company, right? Tabs, packet brokers, inline bypass, and hardware data diodes. So obviously our belief is that the best way to get traffic off a network is via a network tap. And spam ports being kind of the, historical way of getting traffic from a network gathering packets. I know I've used them in prior jobs working with network analyzers for wireless networks. I've used spam ports, but always as kind of a temporary means of getting packets. But for customers that still want to use spam ports, there are some important risks to understand. They may be completely impossible to have access to a spam port if you're dealing with unmanaged switches, which is pretty common in OT networks. But they can be oversubscribed, and so you can mirror too much traffic out of a single port and drop packets. They're a big cause of duplicate packets, which just makes your tool or appliance work that much harder to process it. They can be bidirectionally configured, so they're configured by a human, right? So they can be misconfigured to get the incorrect packets, where taps were getting 100% of the packets all the time. And then you've got your other issues, but the big deals are just a cause of exploits, and they're just not a foolproof way of getting packets off the network. So it's important to understand the risks with spam ports. So again, taps are engineered and designed to get 100% of the packets off the network all the time. Jake already mentioned this a couple slides ago. Most of the taps that we sell, the majority of them, and the ones we do sell that have an IP address or accessible are only to set up filters. There's no way to turn the traffic off. But the point is, they're invisible to the hackers or somebody that's trying to look into a network and see where traffic may be fed to a security tool. Spam port can be turned off. A tap is just sending packets, and nobody's going to know about it. So they're completely invisible in the fact that they don't have a MAC or IP address. They're always designed with a fail-safe, fail-open design, or they're completely passive. In the case of a fiber optic tap, they're just splitting light, or with the copper tap, there's a relay that closes, and it's just a piece of wire and allows traffic to continue to flow on the network side. So we're always protecting the network with our tap designs. Easy to plug and play. We always like to say all of our products are designed to be set and forget. You don't want to be staring at a GUI for a tap or a packet broker all day long. It's just a configuration thing. Most of them have dip switches on the back to set them up, so they're really easy to configure. Go ahead, Jake. So this is just a picture of a basic portable tap. You'll see a lot of these green boxes with 4 ports on them that will fit in a 1U rack mount plate. You can put 4 of them in a rack mount plate that we sell. But they're simple, easy, cost effective, no subscription fees, no feature fees. That's an important thing to remember when you're working with Garland. We want to be affordable. Nobody's buying taps just to buy taps, right? We're feeding something, right? So we're an enabling technology to help you guys get better visibility to the network, and ultimately help the customer realize their investment in your appliance and Darktrace's product going forward. We have IT and OT. Jake brought up a slide a few slides ago that showed like 10 meg to 10 gig. I think we do have taps that can operate all the way up to 400 gig. We were just kind of using OT, those speeds, as the common speeds we see in OT networks. And we have a really large selection of taps. We are MSA compliant, so that means that We can work with anybody's transceivers. We do sell transceivers, but you don't have to use Garland transceivers. We won't void your warranty if they work and you have them. Great. So how does a tap work? So this is just a simple drawing, a portable copper tap here. So if you take the green tap out of this picture, you've got a router and a switch with a link between them, a bidirectional link, indicated by the blue and the red lines there. And when you insert the tap in line, you still got your network connection going between A and B. So this router and the switch are still talking to each other. And the tap is creating copies of the packets. So that's what we're trying to show with the dotted lines there. So the C and the D ports are the copies of the packets, and the C is the, the blue direction. So router to switch, D being switch to router is indicated by the red, and we're feeding a tool in this drawing, but it could be, it could be other devices, aggregators, packet brokers. We'll get into more of that as we go along, but that's how a basic, tap works. Again, we have a fail-safe design or fail-open design. In the case of a copper tap that needs power because of its electrical nature, if the power is removed for some reason, maybe intentionally or somebody accidentally unplugs it, we do have locking power connectors in the back of the taps that helps prevent that. But in the case that power is removed, there's a relay that closes between the A port and the B port in this tap. So the router and the switch continue to communicate. You would lose the monitor ports momentarily. So that's a copper tap. On an optical tap that's unpowered, completely passive, we're just splitting the light, a certain percentage of the light to the monitor ports with a little prism internally, and that's passing traffic all the time. So all of our taps are going to have some kind of design to prevent it from being a failure point on the network. Our hardware data diodes are, just as the name implies, a product to ensure unidirectional traffic flow. On the PCB that's in the device here itself. So we're doing, several things. Use cases are possible with the data diodes. The kind of the biggest one or one of the larger ones for OT networks is in the case of a customer using a span port, we can ensure that spam port is unidirectional with a diode. So connecting it right there to port A, and then what we call regenerating or regen mode on our tap. We're sending that traffic out C, but we're also protecting the traffic from coming off of that tool or whatever it's connected to. If that is hacked, there's no way to inject packets back into the network through the span port to the switch. And then on the right hand side here, we're showing if we've got multiple products in different options with our diodes, but this one has two separate ports that will accept traffic. So we're protecting traffic going from C to A and D to B. So that's impossible. It's physically designed to allow traffic to just flow that one direction. Packet brokers are, we've got a lot of different packet brokers, shapes and sizes. Usually they're the larger devices with more ports. That's not always true. We do have a little small portable packet broker, but usually they're going to be 10 to 40, 50 ports, and they're designed to sit in the middle of your ingress traffic sources and your egress devices. So your tools, security tools, monitoring tools, other packet brokers, wherever you need to get the traffic to go. And we have a tap to tool philosophy, so we're kind of working backwards. We always want to look at the tool, what does your appliance require as far as the physical interfaces and the amount of traffic, the kind of traffic that the tool needs to see, and then work backwards. So we're taking the span inputs if the customer still uses span ports or monitor ports off of our taps. encapsulated traffic like ER span, feeding it into the packet broker, and it's like a traffic cop, right? So it's applying different things to the packet stream. Is indicated by those white labels down below. So aggregating, filtering, load balancing, those are the kind of the primary use cases. Also tunneling. So in a remote site, and I think we have an example of that coming up here, where you got a remote site and we can use a customer's network to tunnel the traffic using GRE or VXLAN, one of those encapsulation protocols. Tagging traffic with IDs, so VLAN IDs, so you could be mapped to a physical location on the tap side. So somebody's got a remote building and they don't know exactly where that tap is located. As far as the building, we could tag it with a VLAN number so that they can map that to a location. Deduplication is a biggie. Sort of removing the duplicate packets from the packet stream. That way we're just lightening the load on your appliance. And then other features like packet slicing, time stamping are kind of not used as much, but they are still available depending on the model of the packet broker the customer selects. The main thing is those features down in the white boxes there. We don't charge a recurring fee or license. So that's where customers that we have are getting business that have an incumbent packet broker vendor are spending a lot of money in these feature fees and licensing. You buy a box from Garland, you own every port's turned on, every feature is active, and the only recurring charge is if the customer wants to keep the device under warranty. Okay, so we've got some use cases we wanted to go through with y'all.
It's just one thing to add real quick before we jump into these sizing situations is a lot of you now, especially taking up more and more OT calls and having to do discovery and to see, okay, are any of our clients mapping out to certain compliance frameworks? And Jake kind of went into it, how they're able to adhere to certain NERC SIP rules and regulations that way, right? We're going to hear a lot more with 62443. And we brought up, okay, aggregating data or sending data in one direction only, right? Especially for any types of 62443 compliance, which a lot of you are learning now or having to know more about in our calls, is that's going to help with some of that segmentation between zones and through those conduits, right? Especially as they do their risk assessment. A lot of our clients are doing these risk assessments right now, especially if they're ramping up new sites that they want to deploy Darktrace at. And they're going to have to put a security level on that. May that be 1 through 4, right? And with this regard, using taps or unidirectional diodes, that can definitely help us to say we can definitely make sure that it's as segmented as possible and data is flowing in one way, especially for sites with that security level 4 stamp to it that you've identified through your risk assessment. So keep that in mind that as you're asking more and more about their compliance and what they're trying to do, then think and how, not only from a Darktrace deployment perspective, but if we bring in Garland, how we can communicate that as well to say, hey, depending on where we're deployed, we're going to make sure to cover everything you need and remain at that compliant level that you're working towards. Thanks, Todd.
Thanks, Jeff.
So I think one thing that's, important to get across is truly in OT, and there are no two customer designs that are going to look the same from the Garland standpoint. We very much care about, right, what does that physical environment look like? What does the plant layout? What is the substation layout? And that's in terms of things like, right, speed, media type, location. Are the switches managed or unmanaged again? Or, of course we care about throughput because that helps us make determinations, but understanding some of the things that we look at when customers are coming to Garland or talking, and we're kind of working through our minds of how do we think about making certain product recommendations. It all comes back to the network. So we're going to go through a variety of use cases. They're all very different. Some are very simple, some are much more complex, but it's just designed to show you, right, there's a lot of different options and ways we can help Darktrace deployments. So for this first customer, so this was an example where it was Darktrace on IT, and we've had a lot of these different scenarios where, right, traditionally deployed in the network, now they're looking to migrate over and add that coverage to the OT network as well. But this specific customer wanted to make sure they were isolating the IT and OT networks from a security, risk, and compliance standpoint. But they did not want to do anything that could negatively impact what the IT team was currently seeing from a traffic visibility standpoint with Darktrace. Right, and what also happens a lot with Garland's projects, because again, right, OT networks can be so varied, it's done in phases. So we'll very often talk about things like an initial phase, it might be one or two sites, and then we'll expand the scope in the future. Sometimes that's in a year, sometimes it's on a schedule that it's, you know, every month, every 2 months, we do another site, another location, etc. So this particular customer, they were utilizing Span to, you know, send that traffic to Darktrace, and they were happy with what they were receiving. So we obviously didn't want to do anything to impact what they were currently doing from a visibility standpoint. Other considerations, you know, the customer mentioned to us was they were running on, you know, primarily a fiber network of 1 gig, 10 gig, but they had plans, and that would be addressed when we get to phase 2, that there's going to be some migration to fiber. So we're keeping in mind, what is that media type, what is that speed type, and how do we ensure that Darktrace for IT is still having, that team is still seeing that same visibility as the OT team wants to see. So that led to a very simple solution Todd will talk about.
Right. So this is a, you know, a scenario where the customer is wanting to continue utilizing the span port on the switch. The nice thing about we've got a line of products that are, you could consider span aggregators or span regenerators or replicators. So you've got the IT side and the OT side wanting to see the same traffic. So we're taking that span port off of the switch, and we're making 2 copies and sending that to the IT appliance and the OT appliance. And then we're also maintaining that separation, you know, enforcing that unidirectional traffic flow with the data diode design. So this is a span regeneration span tap. We kind of use those terms sometimes interchangeably. It gets a little confusing, but this is a span regeneration data diode. So making 2 copies of that span traffic, and then not allowing anything to go back the other direction. Right, so two traffic streams with the same traffic. You know, it's just a little portable device. You know, like I said, we can put 4 of these in a rack mount plate. You know, 1 for IT and 1 for OT. You know, very cost effective. For something like that, you're talking about you know, somewhere around $1,000 or $1,200 list price. So a very affordable way of getting traffic duplicated and off to the OT side as well. And as Caitlin mentioned, they're going to be going to phase 2. They'll be, you know, going to fiber. So there's no reason to rip out the span data diode. We have devices that can be, you know, equipped with different SIPs. So if you change from copper to fiber, it's just a matter of changing out the transceiver and then plugging in the fiber on a lot of our products.
Okay, so that was, you know, a pretty simple solution, something we come across all the time. You know, this customer design is, I would say, more indicative of what we see across a lot of OT, and that it was very geographically dispersed, right? We know there can be large distances between networks that are sometimes connected, sometimes they're not connected. This particular account, one of the very unique things was that it was connected by, you know, radio for RF signals. And that was really the only way the sites were connected as we were going through this discovery. There was no redundant fiber, no spare fiber. They weren't looking to encapsulate traffic. So we had to write, how can we figure out how to get traffic from all of these remote sites back to where a more main central location where tool stacks and Darktrace was going to sit. And then the other thing, right, we're coming across very commonly in these OT environments is there's not any uniformity. So you can't say, great, this solution design is going to match exactly from site to site to site. That's where we really care about what those physical network requirements look like about media, speed, port counts, number of links. That's going to help us come up with a design. Floor, it looks like you have a question.
Yeah, I'm still kind of confused on the other design, the North Star Blue Scope steel.
Sure.
I'm trying to understand how, like, if we're keeping OT and IT segregated, how we're using like one span session, because that's, yeah, I'm just trying to figure out, because like if it's like only OT, then I'm assuming we would only mirror like the sites that only have OT devices on it. I guess I'm trying to figure this out.
So I believe in this specific location, it was coming off of a core switch. So it wasn't a lower level switch at a specific site. It was up at the core location. And that's where this is more of a phase one approach. So one stream of traffic sent to IT, one stream of traffic sent to OT. In future phases, there'll be increased visibility to lower levels of essentially the Purdue model to get lower level asset visibility.
Okay, thank you.
Yes, I was actually I've been working with this customer for this POV. So this initial site had a remote location where they wanted to tap a link between a switch and a PLC, and there are a couple different things going on, and this is where it gets important, as Caitlin mentioned, that we understand the details of the network, right? So we initially shipped out a tap, and the tap is so in the green rectangle there, the far left hand side device where the switch and PLC are plugged in. We initially sent out a device that was for 1 gig only, and it turned out that this was a 100 meg link on copper. So there's some details on why that's important, but we do need to understand the media type and the speed, because it does make a big impact on the products that we select. So this was kind of a customer not really knowing what they had at this remote site, and so it was not a big deal. We just had to ship them the correct tap, but it's just just kind of hammers home that important detail. So we're taking the copies again, the two different directions of traffic, and we call that breakout mode. So we're taking each direction of traffic on C and D over to that device on the far right hand side of that bracket, the GAA 10G 10AC. That's a small 10-port packet broker. So that's the smallest device that we sell that can encapsulate traffic. So we did layer 2 encapsulation on this traffic, and then aggregated the two streams there, the switch and PLC traffic, out of a single port, and then plugged it into the customer's switch. And so then we use the customer's network, and in this case they actually transmit that traffic over a radio or microwave shot, and then drop it off at the head end where your Darktrace appliance resides. So then another unique thing about this design is that I was able to find out during the design phase of this that you guys were able to you're able to encapsulate this GRE traffic. So that's not always the case. We work with a lot of tool vendors that are not able to de-encapsulate traffic, so we would have to put another packet broker there and strip the header off. In this case, we just handed it directly to you guys, and then you decapsulated the layer 2 GRE header, and then took the packets in, and then worked your magic on that. So we've got a couple different sites in the phase 2 of this POV. One where we've got a tap that P1G CCAS plugged into one of your small mini sensor or mini appliance. And then I think the other side was just directly from a span port into your appliance. So a mixture of ways to kind of skin the cat here with this customer. But this one was a fun one. It was a little different, being a radio link involved, and how are we going to get the traffic? Because when you've got remote sites, the question, this question comes up a lot. Do you have the customer have fiber going to their different, their remote buildings or remote sites? A lot of times they don't. So if there's no facilities to get the packets back from the remote sites, we have to employ some encapsulation scheme using GRE or VXLAN, and then use the customer's network to transport to the head end. And a lot of times if there's a lot of traffic out of these remote sites, and we don't want to impact the customer's network with additional traffic, we can use filtering on the packet brokers, right? So we can packet slice, or we could remove some extraneous traffic, like the customer that didn't want to send their the security camera video packets. They wanted to remove the actual the video from the packet stream, because there's the security sensor. It was no benefit. They did want to see the control traffic, but not the user plane. So we used at the remote side 100 meg tap, and then connected it to the packet broker. The packet broker was handling that encapsulation at layer 2 using layer 2 GRE, and not having that second packet broker, obviously saves the customer money and simplifies the design, that you guys are able to handle that decapsulation. It's great for everybody involved. And then that we needed to actually use the customer's network because there was no fiber, so that was the reason for that. So that's another reason. If you're talking about trying to gain visibility or remote sites, we need to understand what's out there. What does that network look like at the remote site, and do they have fiber running to those remote locations? A lot of times they do. There's some spare fiber that we can utilize, but sometimes they don't. So we have to follow with this encapsulation design.
Okay. Todd, you also mentioned speed as well.
Yes.
Can you go a little bit in that, what that means?
Yeah, so we're when we say speed, we're talking about the actual link speed, what the link comes up at. So 10 meg, 100 meg, or 1 gig, 10 gig. So not the actual, you may have a 10 gig link with 100 megs worth of traffic running through it, and then that may fluctuate based on time of day or what's going on. A lot of times in the evenings when folks are doing their backups, the utilization goes up. But what we're interested in is what is the link speed. So it's in OT, it's a lot. Most of the time, it's 1 gig copper. And this customer had a drawing. I remember they had like a legend on the drawing, and I think it was a red line, I believe, and it said 1 gig. And I just made the assumption that they had a 1 gig copper link, and it actually ended up being 100 meg. Nobody's fault. It was just a mistake that they thought they had a gigabit link out there as well. But it's important for us to understand that, because if you can go back to that drawing, Jake. Yeah, thanks. So coming off the monitor ports on the tap, the P1G, since we connected up at 100 meg, those monitor ports ended up being 100 meg. And why that was important in this design is the GAA that supports 1 or 10 gig ports. So it didn't connect up at 100 meg. So we had to send a tap out there that could take the 100 meg link on the tap side, on the A and the B side, and then convert the speed up to 1 gig, so we could plug it into the packet broker, so it will accept the 1 gig feed. So we need to understand, the media, is it copper, is it fiber? If it's fiber, is it multi-mode fiber, is it single mode fiber? And then the speed. Those are the speeds and feeds I'm always asking customers to give us details on that. It's kind of difficult sometimes not to, if we don't have those details, to put a design together. So Scott, looks like you have a question.
Yes, sir. Hey, Todd. Hey, quick question. So kind of the flip side of that. So Darktrace currently has a limitation about 40 gig ingestion with probably at 50% of that. So let's say 20 gig.
Okay.
Line speed basically. Could we utilize this to capture traffic at, let's say, 100 gig wire speed for large enterprise and then funnel it down where we could ingest at 20 gig and
Yeah, it's
still
really
have the
good.
timestamps and everything?
That's really a good question. So this something that honestly customers don't really understand or know a lot of times, right? They know they have all these links, they know what the speeds are, they may even know the utilization, but they don't understand if we tap all these links and aggregate it and send it to their security tool, that the tool may be limited or not be able to process it, or they bought a certain license, right? So to answer your question, yes, you'd have to use some filters or packet slicing, or some method, but we can definitely throttle the traffic down and maintain the traffic flows. So there may be some important traffic that the customer needs to see, and some, like I mentioned, the video stuff. And that was the reason why this customer, I don't remember if they were Darktrace customer or not, but they realized that their security appliance wasn't going to be able to handle as much traffic. So the one thing that they could get rid of was the video traffic. So yes, using a packet broker is the way to do that. We do have some taps that can filter traffic out. But that's kind of on a link by link basis. You're probably looking at a packet broker if you're looking to do that kind of stuff.
Okay, so it's more like a filter versus funneling and
It would be
timestamping.
filtering. It could
packet
be deduping
slicing
out.
or deduping. Yeah. So there's sorry, Caitlin. Yeah.
I was just going to say deduping, or if all that traffic truly is important, it could be a scenario of load balancing the traffic to two different Darktrace appliances.
Okay.
So that you're not, over subscribed, overwhelmed by the throughput requirements.
Okay, perfect. Thank you.
Welcome. Good question.
And a good use case potentially for the filtering is if maybe if the switches themselves don't really have clean ways to do some of those exclusions, right? That's where I've seen it been used as well. So, yeah.
So we can filter on our packet brokers anything from layer 2 to layer 4. So if there's certain IP addresses or MAC addresses that aren't important, or in the in the case of the video traffic, it was a TCP in port 554 or something. I don't remember exactly what it was for RTCP, I think was the protocol we were trying to get rid of. But yeah, so there's a lot of different flexibility with the filters. Okay, any more questions about this one?
Just a comment about big KV. Oh, go ahead. Was that Rom?
Oh, that was me, Jeff.
Oh,
go ahead. Quick question on the load balancing. Does that have to have some kind of schema behind it of, certain VLANs or certain IPs are going to go to one appliance and the rest to another? Or how does the actual balancing work there?
Yeah, there's different configurations you can implement depending on the packet broker. It's a 5-tuple schema, to use your word, that you would choose, and it would, depending on the mixture of the traffic, right? You could have different modes to select, because maybe there's not a big mixture of IP addresses or VLANs, but you want to pick the appropriate one based on how the traffic is kind of divvied up, right? So yeah, we would apply that, and then like you said, that certain VLANs, certain IP addresses would go to the same appliance every time, based on how it was set up.
Thank you, Todd.
You're welcome. Thanks.
Sure. So, one of the other areas that Garland come across a lot in OT is just, deployment limitations due to, span port limitations. So, right, coming across customers as you're having those sizing conversations, and configuring a span port is not an option because that switch is unmanaged. Customers sometimes decide to go the route, well, I'll use this as a time to, refresh my switches too. That can lead to other delays, other, timeline issues, budgetary issues. But this customer specifically also, had some sensitivity around downtime. They were worried about span, what that could do. They felt that their environment would be difficult to place Darktrace appliances across the distributed environment, and having to then, maintain that over time. They wanted an easier, simpler way to make sure that they could, get all the traffic off of their network to, in this case, it was Darktrace. We found out about this project, separately. It's customer reach out to Garland, reach out to Darktrace, and then, we kind of, got brought together, which sometimes happens, right? It's not always, Garland referring Darktrace or vice versa. We find these organic opportunities just based off of customer, conversations and evaluations. And in this place, the one thing we really want to highlight is that they had a ring topology to connect the different rooms to the main data center. This is something that can be challenging to gain access to traffic without utilizing a tap solution.
Yeah, thanks, Caitlin. So yeah, so utilizing that ring is indicated by this is a busy diagram, but indicated by that yellow line there, the single mode fiber ring. We actually, our CEO, Chris Bahari, actually put this design together, and tapping in these different rooms, right? So we've got, taps going on. I know it's hard. This is, kind of difficult if you've never seen one of these drawings before, but there's multiple things going on. You got taps in these rooms. You got span ports coming into a packet broker, and then we're aggregating. The main thing is in each one of these rooms, aggregating all that traffic, either tap or span traffic, and then putting that traffic, copies of that packets on the ring. And then we split the ring because we didn't want to overwhelm either direction. So we split it down there at the bottom between, I think, room A and I. I think we kind of script this diagram a little bit. But anyway, so we're sending traffic between the rooms utilizing that single mode fiber. And that's probably running at 10 gig if I had to guess, and then running it eventually over to the backup server room where the Darktrace appliance resides. But if you also notice that they're feeding traffic to virtual sensors, so they've got some other monitoring tools or security tools, or maybe packet storage or something, some other devices. So that's another good thing about a packet broker is once you have access to the traffic by tapping and aggregating span and getting all that traffic consolidated at a head end, then if you have a packet broker, you can feed multiple tools. It doesn't just have to be one. So the main thing is you get access to that traffic to start. So this is just a example of different media types, fiber and copper and different speeds, and then using, our different tap devices or packet brokers, and making everything common, then handing that off to Darktrace. I don't know without looking at the actual notes exactly what speed we're handing off to you guys, but I would guess it's probably 10 gigabit. But there's a lot of different physical connections, and eventually getting it down to a single handoff. So I guess this is the principal server room. So we're tapping on the packet broker, and then aggregating the traffic, and then sending it out on the ring there, and then also handing it off to a virtual sensor. So yeah, so I kind of went over this already. You know, we've got copper, we got fiber, we got different speeds. You know, in there, if I broke it down and showed you each individual product, there were probably half a dozen different products in that design that we used. If you look at our part number list, we've got a lot of products. So it's important, you know, you can't just have a universal tap that's going to tap all the media and all the speed that we run into. You have to have we have to match the media and the speed with the tap design. To the main reason is to guarantee that fail safe mode. Yeah, anybody could like make a tap that has SFP ports and you know, then plug in a transceiver and connect anything they want. But the problem is once that device loses power and a SFP loses power, there is no failsafe, so you're not protecting the network. So we have to make sure we understand those details. Yeah, look, we're getting close to the top of the hour here.
Yeah, so we'll go through this one really quick just so we can, you know, wrap things up and be, you know, mindful of time. So, you know, this was a little bit different. This was actually a Garland customer who previously had experience to us on the IT side that was, you know, wanting to test out Darktrace for their OT environment. And they needed to be a really quick, very simple POV that was, you know, kind of painless in their mind. And, you know, obviously customers that have experience to Garland in the beginning or maybe in IT can understand, you know, how a tap works. So, you know, having to not have to walk through some of those questions helps to speed up the process and, you know, can get customers thinking forward to, okay, what does a full deployment look like? What does our network scope look like? What do all the different tools we're going to send traffic to look like? Helping to, you know, come up with an easier, quicker POV to be able to test out for customer environments. And this customer particularly before they, you know, came to Garland originally, when they were looking at adding in Darktrace, they were experiencing on their OT side of things, dropped packets, which can be very common with span port connections. There's limitations to what a span, you know, is considered as priority. They can be oversubscribed. So, right, when customers have critical links in areas that are really important to be monitored by Darktrace, utilizing, you know, a tap is going to be that best practice to ensure that complete visibility.
Yeah, so I think we're just showing the one of the sites here. So they had 2 rooms at the first site, an IDF and the looks like room 002 there, and then MDF in a different room. So we're using fiber taps. So the boxes at the very top with the individual devices you see with the LC connectors on there, maybe you recognize that. That's a fiber tap chassis. So we've got looks like 12 25 gig single mode taps and then 4 10 gig single mode taps, and then we're taking the monitor ports of that and connecting that to a packet broker, and then we're doing so that's at the IDF, and the MDF has 7 single mode taps in it at 10 gig, and then we are sending the traffic to 2 separate packet brokers, the AF 25G 80 DAC, and then connecting those 2 boxes together with 100 gig connection between them so that all the traffic ends up on one box ultimately, and then we send that traffic out to Darktrace over 4 single mode 10 gig links, and that traffic is load balanced across there to keep the traffic spread out across the interfaces there. But yeah, so I mean, we do these drawings for most of our customers. It's just a way to put a picture in front of them where they understand what we're proposing, and so, you know, picture's worth 1,000 words, as we say, you know. It's called Design It. We do a quick call with the customer, just hopefully a quick call. You know, sometimes it takes a little bit of digging, but most of the time we can get down to the bottom of what a customer's looking at in their network with a, you know, hour call. Put a bill of materials together, and then we'll do the Visio design like we've been showing, and we call that process Design It. It's a free service we offer. It's something I do in my job all the time. We have a couple of other SEs that do that as well.
And I'm just going to skip to the end here with the time approaching us. But one thing we do want to highlight, right? Bringing in Garland, as you're having these initial conversations, these initial scoping conversations, will just allow the process to be much more simpler, not only for you but for the customer as a whole. So anytime you guys are having conversations and visibility gaps are being discussed, or the customer's using a span port and there might not be enough ports available, or any sort of multi-site deployment, right? That's a great time to just bring Garland into that conversation before it gets too far down the line. In that case, right, we'll come in and we could do our best, but if we're brought into the conversation much earlier, it's just going to be a much simpler process overall. And anytime, right, the customer's talking about budget sensitivity, or any POV and POC, that's a great time to bring Garland into the fold as well. Any further questions, you could reach out to Caitlin and myself at the partners at Garland Technology at. That goes right to the two of us, so we'll be, the first to respond. Or you could always reach out to Todd directly as well. Any questions or any projects, you could reach out to the three of us, and we'll get you connected to the right salesperson as well. We appreciate, you all taking the time today. I will share this recording with Jeff as well as some other pieces of documentation that we've created over the past couple of years that just kind of highlights the Garland and Darktrace partnership overall. But, really appreciate everyone taking the time today. And Jeff, really appreciate you helping us put this together.
Of course. Thank you, Garland team. This was really insightful. And hopefully for everyone here, as we're going into these next sizings, especially as they're getting more and more complicated, hopefully this primes you to kind of think a little bit out of the box. Like, what can we do with Darktrace? And all right, when would it be good time to reach out to Jake and Caitlin and the team to say, hey, I think I can utilize you guys? Because they're not going to be mad. Even if you're like 50-50, like, here's what it is, like, they'll have an open channel with you to say, yeah, it does sound like a use case, or no, like, we need a little bit more info. So even if you're 50%, feel free to reach out, start that conversation, because the earlier you can get them in, right, or have somebody in there, the easier that POV process is going to be.
Yeah, we're here to help you guys. So any interaction that we can help you guys out with, we're here to do that. So appreciate everyone's time. I know we're at the top of the hour, but we'll get all this recording and documentation sent over to you, Jeff.
Sounds good.
Yeah.
All right.
Have a great afternoon, everyone.
Thanks, everybody.